Good morning to all of you and welcome to today's webinar. Welcome to the attendees from India and abroad. I am Nitesh Jain from Be Singular team. These webinars are brought to you from Be Singular. Be Singular is a unique learning platform that empowers the next generation to create real and responsible impact in the world by working with the technologies of the future. We teach exponential technologies to make our next gen better place to solve global great challenges. We also have a Be Singular Exponential Leaders Club, which is a by invitation club only, and it comprises of a community of young dreamers who wish to work together to help change the world. We do our programs in a phygital mode, so which means in a physical centers and also online. Please visit besingular.com to check on the courses and our teaching methodologies. Be Singular Social, which has put together these webinars, is a non-profit entity that has been launched by Be Singular in collaboration with The Banyan, a leading child daycare center chain. Our objective is to invest our resources to help foster exceptional educational experiences and learnings for the families. I have a pleasure to introduce today's speaker, Ramez Naam. Ramez is an American technologist and a science fiction writer. During his career, he has been a computer scientist at Microsoft for 13 years and led teams working on Outlook, Internet Explorer, and Bing. At present, he is an adjunct professor at Singularity University, where he lectures on energy, environment, and innovation. Ramez's session today will touch upon global pollution and how most of it is caused from burning of coal, oil, and gas, which darkens our skies, clouds our rivers, destabilizes our climate, and kills millions of men, women, and children every year. Presenting to you today from Be Singular Social, my very dear friend, Ramez Naam.
Thank you, Nitesh. It is an honor and a pleasure to be here. Thank you, and thank you for everyone at Be Singular. And it's a delight to be able to speak. So hopefully you can all see my screen today. I'm going to talk about how we create a cleaner future for our planet and for all of us that live on this world. So you've heard a bit about me from Nitesh. I will say that I am at Singularity University, and for those who don't know Singularity, we focus on two things. We focus on exponential technologies. These are technologies like computing that get cheaper every year, get a price performance that's doubling every year. So you can imagine the price of computation is dropping by half every year and a half. It means every decade it drops in price by a factor of 10. Every 20 years it drops by a factor of 10,000. Every 30 years it drops by a factor of 1,000,000. So it's a very powerful process, and there's other technologies like 3D printing or biotechnology, AI, that are following similar trends, and I'll be talking about energy. That's the technology side, but we also talk about how do we use this technology to address the greatest challenges on planet Earth. And you see a list of some of those challenges down below: health, water, energy, the environment generally, food, education, so on. These are challenges that affect billions of people on planet Earth, and technology, if we make the right choices and harness it, can be very powerful for addressing all of these. So today, in addition to that, I'm an investor in clean energy startups because I think they can make a massive difference in addressing some of these challenges of energy, environment, and climate. One of those challenges that gets ignored sometimes, especially by people in highly developed nations, is the topic of electricity. Because we say we need to clean up energy for the sake of environment and climate change, but we can't ignore that more than 1 billion people, around 1.3 billion people on planet Earth today, don't have electricity, and another 1 billion have very low access to energy. And to help end poverty and pull people into a global age of abundance and prosperity, we need to address this. We need to deliver more energy to more people. Nearly half of these people without electricity, by the way, are in India and South Asia broadly, with the rest mostly in sub-Saharan Africa. So this is a major challenge. At the same time, the way that we produce and use energy today is deadly. This is from the World Health Organization. It says 5 million people. The latest numbers actually say about 7 million people every year die from air pollution. And about half of that air pollution is caused, or maybe almost 2/3, by the burning of coal and by emissions that come out of our automobiles broadly. And so that is incredibly deadly, and we all live in it. We live in smog sometimes, so we'll talk about. This is Delhi, and this is Delhi last year, and you can see the air pollution. And air pollution is something like the #3 killer in India today. And so you see how when we just live in this, when you see this, it's not just cutting your visibility, it is literally producing small particles in the air that increase the risk of heart disease, of lung cancer, and other things. Now, it's fascinating because today we are all in our homes because of COVID-19. And as a result of that, with far less oil being burned, with less automobiles on the road, especially, and secondly, with less coal being burned as we're consuming less electricity, you can see a massive change in air quality. And here you see Delhi about a year ago and Delhi today, or just about a few days ago. And the difference is striking, right? And so we know that our air will get cleaner, our water will get cleaner, we will live longer lives with less lung cancer, lung disease, heart disease, if we clean up our air. But the way that it's happening right now is not the way that we can take, because who will choose to stay in their homes or shut down the economy, shut down businesses, if the choice is between air pollution or an economy that has completely come to a stop? Frankly, people choose air pollution. We all have to live our lives. We have to deliver food to people. We have to get electricity to our homes and so on. And so we won't take a path of cleaning up our planet if it means incredible sacrifice to our economies and our lives. The other challenge is air pollution is very local. It's very here and now, but we have this global challenge of climate change that is a massive problem, that all of those grand challenges that I showed you at the beginning, environment, poverty, water, food, all get worse because of climate change. The planet is warming. Scientists tell us that we really need to stay below 2 degrees Celsius of warming from pre-industrial times, and we've already warmed up about 1 degree Celsius, and it's getting faster and faster. It's not every year is warmer than the last. You see the numbers go up and down, but as you zoom out to the big picture, you see the numbers are just going up, the planet's getting warmer, and we know very well that this is tied to the amount of carbon dioxide in the atmosphere. Carbon dioxide comes from our burning of carbon, coal, oil, gas. This image is showing 500,000 years of carbon dioxide levels in the atmosphere and temperatures. We have this from ice cores pooled in Antarctica, and you see the correlation here is extremely tight. And you see on the far right, our CO2 levels are now, they're actually in excess of 400 parts per million. That is a level of carbon dioxide in the air that we haven't seen in about 7 million years. And 7 million years ago, humans did not exist. So all of our civilization and basically all of our species has lived with a lower level of carbon in the atmosphere and lower temperatures than what we're headed for right now. And so if we keep emitting at the rate, the growing rate that we have, when I started working in this field about 10 years ago, the forecast was we would see something like 6 degrees Celsius of warming. And that would have drastic impacts. For a contrast, at the middle of the last ice age, the temperatures were about 4 degrees Celsius lower than today. So this is a bigger change than from the Ice Age to today. And it would have a massive impact of increasing drought, of killing forests and nature, of massively impacting our food production, making farms less productive, killing crops, of harming things like barrier reefs. This is a Great Barrier Reef in Australia, and a lot of the world's fish actually grow up as young fish on these reefs. And what we see is this image was from a few years ago, and now we've had the third massive bleaching event in just the last 5 years. I've swum and scuba dove on this reef, and it is just changing incredibly. And similar things are happening to the world's forests and so on. The good news is that the way that we produce and use energy is being disrupted by a mix of technology and policy choices that we've made. And so there's no better example of that than what's happening in coal. Now, coal is the largest energy source on planet Earth. It's the largest energy source in India, and yet there is a real change happening here. The pictures you see on the slide right now, these are the logos of 8 of the largest private sector coal companies in the US, where I live. Or these were the largest private sector coal companies in the US. All of these companies have gone bankrupt. In the case of Peabody Energy, which was the single largest private sector coal company on Earth, they've gone bankrupt multiple times now. They come out of bankruptcy and then they fail again. And coal stocks on the stock markets have been plunging in price. And that's happening even though coal is still the largest energy source on Earth. But what's happened is that we've had a change, because for almost 150 years, from when we had the beginning of the Industrial Revolution, in 1850, we had the steam engine invented. From 1850 to about 2013, coal consumption basically rose everywhere on Earth. And what happened is that in 2013, coal stopped growing. We hit a plateau or a peak. And since then, it hasn't dropped a lot. It's stayed at very similar to that level. But when we've gone from a growth area to an area that has stopped growing, that is really hard for the companies in that sector. And that has real impact on people's jobs, people's livelihood, and so on. But it's fundamentally a very positive thing for all of us that have to breathe the air and live in a world that's changing. And this has happened for a number of reasons, but one of the biggest reasons, and the one that's most important going forward, is that clean energy is also an exponential technology. I told you that the cost of computing drops by half every year and a half. It's not that fast, but it's enormously fast nevertheless. This is the cost of wind power, the cost of solar photovoltaics, the cost of offshore wind power. It's a new area. And just over the last 10 years, you see that they have all plunged in price. And that shaded area is the cost of generating electricity from coal and gas. So we're entering a world where it's just plain cheaper to create electricity with clean sources than it is with dirty sources. And so to give you examples of that, I'm going to talk numbers for a bit, and my apologies, this is in US dollars and cents, but we can translate a bit to rupees if we like. In general, around the world, if you're building a new coal or gas power plant, the electricity produced from it is going to cost you around 5 or 10 US cents per kilowatt hour. And to disrupt these dirty industries, basically clean energy has to be cheaper than that. And so let's start with wind power. Wind power has been around for ages, for decades, really for centuries if you go to the Netherlands, for instance. But it's always been more expensive than coal or gas. But that has changed. So we now see in the last almost just 40 years, the price of wind power has dropped by a factor of roughly 20. This is US prices. Now we see on the far right of that, you say about 3 cents. In India, we have wind deals with no subsidies at a little bit over that, 3.8 cents. That's still cheaper than using coal or gas for electricity. And so you see this is happening around the world. Anywhere that the wind is good, we're seeing it come down in price. And so for most of history, wind was in this first phase where it was dependent on policy, where only if a government said, we have to deploy new wind power, was it affordable. It was without those government policies, it was always more expensive. And then suddenly around 2015, that changed. And we started to see wind power that was just cheaper, that was in a second phase, where it was price competitive without any subsidies in different countries around the world. And so it gets cheaper as we scale it. So as we build more wind power, really with any exponential technology, as you deploy more of it, it goes from being very expensive early on to being a larger industry, which means that people in industry can devote more time to research and learn to make things better just by practice. That makes it cheaper, and that brings it into new markets. The other thing that's happening is the rise of wind, not on land, but offshore. This is a map of wind speeds around the world. And what you see is that in many parts of the world, the fastest winds, and this is true of India, Europe, the US, the rest of Asia, the fastest winds aren't on land, they're actually offshore. The wind blows faster where there's no obstruction over the sea. Now, historically, building these offshore wind turbines has, even though the winds are great, has just been expensive. Building things out in the ocean is more expensive than building them on land. And so for most of the history of wind power, people thought offshore wind over the sea would never be cost competitive. But just in the last 3 years, we've seen bids, especially in Europe, where offshore wind is cheaper than coal or gas electricity. That's France and the UK. And now we see this price has dropped by a factor of 4. And now the new frontier of offshore wind is really the US and Asia. So the US East Coast, India, Taiwan, China, Japan. We see a huge amount of offshore wind in planning right now. So this is the most expensive wind power will ever be. This is something we say frequently in exponential tech. Pick any technology. It is the worst it will ever be right now. It's the lowest quality it will be, and it's the most expensive it will ever be. If you think about your mobile phone, guess what? In 5 years, phones will be more powerful, have more features, and will cost less, and more people have access to them than they have today. And the same thing is happening in clean energy. It's going to get cheaper and better. But wind power, as great as it is, looks slow and stagnant compared to what's happening in solar power. If we look at just the cost of solar photovoltaics, the solar panels themselves, the cost of them per unit of energy they put out, per watt, has dropped by an enormous factor of 350 over the last 40 or so years. That is unlike basically anything physical. It's only compares to the cost of information technology. And that means we now have crossover where in the sunny parts of the world, solar is just the cheapest electricity you can buy even without subsidies. So again, we have to be cheaper than this, 5 to 10 cents. So we see in China, now the price the government pays for solar is about 5.6 cents in sunny provinces. In solar on rooftops, not big scale, but solar on buildings, has dropped by a factor of almost 25 in price in the last 20 years, just enormous. India now is becoming a solar superpower as well, and that's largely because India is much sunnier than China. It's actually quite a sunny nation, and so now we have solar projects being built in India for 2.4 rupees. A new coal project is maybe 3.2, 3.3 rupees, or that's about less than 4 cents US. So that's cheaper than building new coal or gas. The price of solar power in India dropped by a factor of 4 just in this 2013 to 2017 period. It stayed at about that level now, and there's some reforms the government needs to make, but fundamentally it is just plunging in price. In the US, where I live in Los Angeles, we've had deals at less than 3 cents in sunny places like Los Angeles. The price of solar, full cost of building the whole project, has dropped by a factor of 10 in the last decade. And there's new records being set everywhere around the world. The cheapest we've seen so far is in Portugal. This is 1.6 cents a kilowatt hour. That is about a third the cost of the cheapest new coal or gas plant that you can build. That is cheaper than electricity, than the price of the coal going into a gas plant. And this is not just the cheapest solar we've ever seen, this is the cheapest contract for electricity ever signed anywhere on planet Earth. Though now we have competing prices in places like Dubai, Saudi Arabia, the Middle East, Mexico, that are similar to this. Anywhere that's sunny, and including in India, we'll see cheaper and cheaper prices over time. So just like wind power, solar has gone through these two phases. First, where it had to be subsidized, and now where without subsidies in large parts of the world, it is just cost competitive with coal or gas. And basically, in all of these parts of the world that are getting highlighted now, there's enough sun that solar is today, if you can borrow the money to build it at a reasonable rate, cheaper than building coal or gas. And it will keep dropping in price. Every time we double the amount of solar in the world, the cost drops about 30%. So it goes through this cycle as well. And so we could see prices by the time solar is mature, by the time it's a substantial fraction of our energy, at less than 1 cent a kilowatt hour. This is less, maybe it's 2/3 of a rupee, something like that. These are incredibly low prices that are possible. And so solar power, this is the worst solar power is ever going to be. It's going to keep getting cheaper and better over time. But of course, the sun doesn't always shine, the wind doesn't always blow. So the next frontier is, how do we store this energy? There is some good news even without storage. The sun peaks in the summer and the wind peaks in the winter, and the sun is only during the daytime, of course, and the wind statistically blows more at night so that you can put them together. But still, ultimately, we have to have energy storage. And here, again, we have an exponential technology. You all know who this is. Elon Musk, founder of Tesla, Solar City, SpaceX. I like to joke that he's really the closest thing we have to Iron Man. The reason that he's been able to bring down the cost of batteries, though, isn't some science fiction. It's that batteries are also an exponential technology. And so in the last 9 years, from 2010 to 2019, the price has dropped even further than this. It's dropped by about a factor of 10 for new batteries. And that is now making it possible to store energy at reasonable prices. So that project in Los Angeles came with a 4-hour addition of batteries that was really quite affordable. The solar plus 4 hours is still cheaper than a new coal plant. And batteries will keep dropping. They drop in price at about the pace of solar. So they're just going to get cheaper and cheaper over time. So that's the most expensive today that batteries are ever going to be. Excuse me while I take a sip of water. All right, so one of the things that we talk about in exponentials is that the pace of change is often deceptive. It deceives our intuitions. We expect linear progress. That's how our minds work, and yet progress is exponential. So we show slides like this frequently, which is the black is an existing technology that we know well, something like coal power, or for those that have been around long enough, film cameras. The green is an exponential technology. And at first, any new exponential technology is very low quality or very expensive. And so we think, well, this will never work. Maybe 3D printers are like that. We think it'll never be good enough to replace manufacturing in a factory, for instance. But if it's getting better steadily, if a 3D printer goes from being able to make 1 widget or part per day to 2 parts per day, to 4 parts per day, to 8, to 16, 32, 64, 128, and before you know it, you're at 10,000 parts a day, 100,000 parts per day. And so that's what an exponential looks like. And so exponentials start off very disappointing, or we think they'll never amount to much, but then when they actually pass the performance of non-exponential technology, they're getting better so quickly that our intuitions have just deceived us. So here's an example of that. Here's the International Energy Agency, one of the world's leaders, the leading really organization in terms of forecasting energy. And here's forecasts that they've made over time for the growth of solar versus what's actually happened. The black line is how fast new solar installations have actually grown over time. And the colored lines are every year, this organization, the IEA, puts out its forecast for how much new solar will we install. And they always say, oh, we'll keep installing how much we're installing this year. That's how much we'll install the next year and even 10 years from now. And yet what happens is the actual growth keeps going up and up and up. So this is a linear versus exponential mindset. The exponential is the black, and linear is what people who don't understand the technology is constantly improving tend to forecast. And that's fundamentally because people who think linearly don't expect technology to keep getting better. They expect technology like solar to get a little bit better over time. This chart goes up to 2040, and you see what's actually happened with how fast it's dropping in cost. Similar things have happened for battery forecasts. Here's a part of the US Department of Energy. The yellow line is a forecast they made in 2013, 7 years ago now, but not that far back in the context of energy, of how cheap would batteries get. They said, look, batteries will drop by 1/3 in price by the 2040s. And that's a very long time, that's very slow. Here's what actually happened. And so this is just a massive change in technology and business and in our possibilities of doing the right thing for the world. Then secondly, when change happens this quickly in computing and materials and energy, it massively disrupts existing industries. So in energy in particular, I told you about two phases. That clean energy started off more expensive than fossil fuels and had to be subsidized. Then in the last few years, it's gotten competitive for building a new power plant. But what if you already have a coal power plant built? Like India, more than 2/3 of the electricity sector is coal power plants that have already been built. Well, we're entering a phase now where building a new solar or wind power plant can be cheaper than just operating an existing coal power plant you've already built. And that's crazy, but it's happening. It happened in Indiana, a US state. At the end of 2018, a utility made its 5-year plan and said the cheapest thing they could do would be to replace all the coal power plants they've already built with solar, energy storage, wind power, and demand management, sort of smart control of when we're using electricity. And that was unexpected. Nobody really saw that coming. And so we see this is the cost of coal going forward in the US, or just operating an existing power plant, and here's the cost of new solar. Now, Indiana isn't really that important, it doesn't use that much energy. How about India? India is the second largest coal market in the world. And what we see is that the new cost of solar in India is cheaper than the operating cost of almost 2/3 of India's existing coal power plants. So that's very good news in terms of replacing it. And similar things are happening in China. The cost of running power plants that are coal is going up. The cost of building new wind or new solar are dropping. So before 2030, basically everywhere on Earth, we think it will be cheaper to build solar or wind than to keep operating existing coal. And that means the world's use of coal will plunge with massive benefits for all of us. All right, I've talked a lot about electricity, but of course, the other way that we use energy is to move ourselves and our products and our goods around. And for that, we use oil. Now, about 10 years ago, there was a lot of talk about peak oil, which was the idea that we couldn't get any more oil out of the ground, it was running out, but that turned out to not be true. So I'm not talking about the peak of oil production, but I am talking about a peak of oil demand, like what happened with coal. Demand for coal, consumption of coal, stopped rising after 2013. And I think something similar will happen in oil. And I'm not the first person to say that or the 100th. The first was actually a Saudi. The Saudi oil minister in the past, Sheikh Ahmed Yamani, he was the oil minister in the 1970s of Saudi Arabia. After he retired in 2000, he said this. He said, the Stone Age didn't end for a lack of stone, and the oil age will end long before the world runs out of oil. So the Stone Age was, 10,000 years ago, more than that, really, when we used rocks as our tools. The Stone Age ended not because we ran out of rocks, but because we invented new technologies like iron. And iron is just better than stone. And so what Yamani is saying here is, look, the world is going to invent better technology than oil and engines that burn stuff for moving us around, and that is what's going to replace oil, not running out of it. And he was right, but it was hard to believe at the time because this was an electric vehicle at the time. And so nobody thought this was going to convince people around the world to switch from gasoline. But now we see that electric vehicles are some of the most exciting, most desired vehicles around the world, and they're plunging in price. And so we are starting to get, not there yet, but we're starting to get to electric vehicle prices that are competitive with gasoline vehicles. And so it really started with Tesla, but now every auto manufacturer around the world, including large Indian manufacturers like Tata, are talking about an electric future. And so electric vehicles are still a very small fraction of the world's vehicles, but they're growing at twice the pace of solar. And so again, it's deceptive. Here's a forecast made again by the US Department of Energy. How many electric vehicles with a 200-mile, 320-kilometer range would we have in the US on the roads? By 2040, they said we would have 20,000, which is just a tiny, tiny number. And now one company, Tesla, is selling close to 500,000 cars every year, 25 times that. So this is an example of that sort of being deceived. And the same thing is happening with other forecasts. Every year, all of these oil companies lift their forecast for how many electric vehicles will we have around the world. And indeed, even before COVID-19, it looked like the peak year of automotive sales globally might have been 2017. And gasoline car sales had been dropping the last couple of years. And of course, they're dropping much faster right now. Now, that's still sort of phase one. People are deciding to buy electric vehicles because they like the vehicle for various reasons. But there is a phase two coming where electric vehicles are just cheaper. And this is why. This is what you see on the screen is the entire engine and drivetrain, all the moving parts of an electric vehicle. And if you compare that to the parts of a gasoline or diesel vehicle, you get this. And so an electric vehicle is just much simpler. It's much more efficient. It gets 4 times the range per unit of energy, which means it gets about 4 times the range per rupee or dollar put into it. It has lower maintenance costs because you have far fewer parts, and it's cheaper to manufacture. And so even now, while electric vehicles are more expensive to buy than a gasoline vehicle, they're cheaper to operate. So a gasoline vehicle, the blue area is how much it costs to buy the vehicle, but the orange and yellow area is how much it costs to fuel it and to maintain it. And an electric vehicle costs more to buy, but it's much, much cheaper to power. And so if you look at it of not just what did you pay up front, but what did it cost you over 4 years, it is actually cheaper to buy an electric vehicle today. But of course, electric vehicles are dropping in price because of this feedback loop. And because batteries are dropping in price and are the most expensive part of an electric vehicle, EVs will keep getting cheaper. And in fact, even big companies like Ford says the cost of factories to make electric vehicles will be 50% lower, will be half as much as factories to make gasoline vehicles, and the labor will be less as well. So that means that by 2030, an electric vehicle isn't going to be 10% cheaper. It'll be about half the cost of operating a gasoline vehicle. And indeed, by the middle of this decade, by about 5 years from now, the blue part, just the cost of purchasing an electric vehicle, will be cheaper in most of the world for equivalent vehicle than the upfront purchase price of a gasoline vehicle. And so that's really the moment that this will take off in a big, big way. And so you see, I think some of this is cut off, but even in India, policymakers are now talking about by 2030, maybe not selling any more gasoline vehicles, maybe requiring people buy electric vehicles, and that's only possible because they're getting so much cheaper. And this would have a major impact on India's air quality and on everyone's quality of life. But there's another technology that's coming, which is autonomy and the switch to using apps like Ola, apps like Uber, and so on. And these two trends combine electric vehicles to make them go even faster. And UBS has said the world could spend $2 trillion on this. So autonomous vehicles are coming from companies like Uber. I don't know if you can see the video in high quality or not, but it's showing one autonomous company called Zoox driving around in the streets of San Francisco. And really, we have a number of companies that are working on this. Google or Alphabet delivering, they have 1,000 people or more riding in their autonomous vehicles now. General Motors bought a startup called Cruise. Tesla, of course, is working on this with cameras and software in Tesla cars and deploying more features. And really, almost every automotive company around the world is working on this, and they're just getting better and better. Every year, they drive more miles between human intervention. So now, Google's company Waymo in 2018 drove about 11,000 miles between times that a human had to take control, which is really amazing, and it's growing at a rapid pace. We'll know what the 2019 numbers are soon. And the other thing to realize is that the way that people get autonomy, most people, it's not going to be that they buy a new vehicle. It's going to be that they open an app like Ola or Uber, and when they call for a vehicle to come get them, there's going to be no driver. That's the way it's going to get out to people. And this has the possibility of shrinking the cost of a ride share and of bringing down the cost per mile or per kilometer such that it makes more sense to get into an autonomous electric vehicle than it does to drive your own vehicle. And that will get tremendous numbers of people to switch. So this is massively disruptive. Autonomy disrupts lots of businesses, parking lots, taxi companies, commercial real estate. Real estate, a lot of, in many parts of the world, there's big parking garages or parking structures in city downtown. The auto insurance industry gets disrupted. But of course, the big one from both an economic perspective and from a climate perspective and making our world cleaner is what's going to happen to oil. If we look at the way we use oil, we only use about a little over a quarter of it for our passenger cars. We use more for our trucks. We use a chunk for lubricants in these engines. We still use some for electricity and heat. That's about 2/3 of the world's oil use per day. Its oil demand or consumption per day is at significant risk of being replaced by electrification of transportation. And that's a major, it's a business opportunity. It's a risk for anyone that's in the automotive industry, anyone that's in the oil industry or in the gasoline station, the petrol station industry. And it's a tremendous blessing, really, for those of us that care about air quality and climate. So what does this mean for climate change? I told you at the beginning of this talk that we thought, when I started in this field, that the world would rise by the end of the century by about 6 degrees Celsius. And that's an incredibly bad scenario. That really is, hundreds of millions more deaths. It really is massive drought, agriculture failure that could lead to war, all sorts of things. We don't even know really what the second order effects on society would be, but it's not good. Now, 1.5 degrees Celsius is what scientists really hope we can keep warming limited to. But as I said, we've already raised temperatures by about 1 degree Celsius. So to do this, we'd have to cut emissions by half in the next 10 years, reduce half of the world's coal plants in 10 years, half of the world's cars, and then go to zero carbon emissions by 2050. This, I'm sad to say, I see almost no way that we'll achieve this. Now, if we can't hit 1 degree Celsius, the thing that people started saying a while ago before getting the ambition of 1.5 degrees was 2 degrees Celsius. That would require us to cut half of our emissions by 2040. So we'd have 20 years to replace half the world's coal plants and cars and so on, and then get to zero by 2080. This is possible. It's difficult. It's difficult for reasons that I haven't really talked about here. There's other sectors like cement and steel where we don't actually have good solutions. In electricity, to replace coal plants, we have solutions that are coming, same with cars. But in some other sectors that are important, we don't really have the technology yet, though it's coming. But this is not impossible. But 6 degrees Celsius is also, now I think we've made tremendous, tremendous progress against that. So if we look at different scenarios of how much our carbon emissions could rise, if we basically keep them flat and allow them to rise a little bit, we'll get to 3.2 degrees Celsius. Now that's too high, but it's not probably the end of the world. If we can reduce our emissions by half by 2080 and get to 75% reduction by 2100, the average, the models have some errors in them, but the middle of these models says 2.6 degrees Celsius. And this looks totally doable. This is a long time that we have to develop the technology and deploy the technology in all of these sectors. And if we go a little bit more ambitious, cut our emissions by half by 2060, gives us 40 years, and get to zero by 2100, that's looking at about 2.2 degrees Celsius. That's still higher than we'd like, but I think we can do even better than this. So we're not on path for 1.5 degrees Celsius, but there's a lot of opportunity for us to even hit 2 degrees, and I think we have reduced the odds of these really horrible situations. And we've reduced it through technology, but also through choices. We've reduced it in part because a decade ago, countries like Germany is not a very sunny country, but they started really aggressively deploying solar power. They made a political choice. That's what they wanted to do. And solar cost 10 times then what it does today. And in Germany, there's half the sunlight of India. And yet they made that choice to start deploying solar. And that led to technology innovation that brought down the price and gave a gift to the entire rest of the world, including the US, including China, including India. So those sorts of choices, making a policy to say, we are going to phase out coal, we're going to replace it with solar and batteries and wind, we are going to stop the sale, not all of a sudden, but we're going to gradually phase out gasoline and diesel vehicles and replace them with electric. That choice takes courage, but when you make that choice, you encourage the technology to get faster and better and cheaper, and that's what gives a gift to the world. Now we have to go beyond areas like electricity and cars. We have to solve things like agriculture produces immense emissions and deforestation. Industry, as I mentioned, things like steel and cement, and ultimately things like ships and planes. But I think we can do it, and I think the progress we've made on solar and electric vehicles shows that we have ability to innovate, and these are a couple examples of companies working on that innovation. Now, I want to close by just talking about the history of technology and why it makes me optimistic that we can actually solve this problem. Because I told you about electricity at the beginning, 1.3 billion people without electricity, living in energy poverty. We need a world where people have more energy to climb out of poverty, to live good lives. We produce more food, we have more fresh water, more buildings, and yet we have lower emissions. And some people, some environmentalists say that's impossible. You can't grow the economy by a factor of 2 or 3 or 4 and still have less impact on climate change. And I think they're wrong, and this is why. I went to university, I was born in Egypt actually. I went to university in Illinois, the University of Illinois, Urbana-Champaign, a great computer science school. And the image on the right is a computer called ELIAC. It was the second computer ever built in the 1940s. and it weighed tens of tons, filled up a giant room, drew tens of thousands of watts of power. And a modern smartphone weighs tens of grams, draws thousands of watts of power, and fits in your pocket and is 1 billion times more powerful. How is that possible? Isn't this violating conservation of energy, conservation of mass, something? How can something that uses less resources be more powerful? And my answer is this, and this is the core of B Singular in some way, the core of exponential technology. It's that that phone isn't made of glass and plastic and metal. It's made mostly of knowledge. It's made of scientific discoveries, engineering discoveries, new software. It's made of ideas. And ideas are the most powerful thing that we have. Innovations in science and technology and even in business. Those are what changed the world. And they're fundamentally different than physical objects, because I could break my phone and then I wouldn't have a phone anymore. But we have the knowledge to make new phones anytime we want. And if I give you my phone, I don't have my phone. But if I give you an idea, we all have the idea. And if you give me an idea back, they intersect, they give birth to new ideas that are further innovations. And the right knowledge can reduce our use of resources, can maximize our welfare, our prosperity, can replace scarce resources. And knowledge, ideas, are the one natural resource that we always have more of over time rather than less. And that fundamentally is why I'm an optimist. Thank you very much. It's been an honor. And I think now we can take some question and answer.
Mez, thank you so much. It was an incredible presentation. It